Hi everybody. If you've been keeping up with my posts on Google Classroom, for Honors Algebra 1, you would have seen that the plan is to skip that section that we had started prior to classes being canceled. So 7.5 is what we were working on. We're going to skip that and we're going to jump to Chapter 8. The first section we're going to cover is Section 8.1 from the textbook, and it is all about adding and subtracting polynomials. So throughout this lesson, I'm going to request that you pause the video and give some of these problems a try on your own. So you'll definitely need something to write with and something to write on. And then at the end of the lesson, I have a worksheet that I'm going to upload as a homework assignment. And I highly encourage that if you're struggling with some of those problems on the homework assignment, go back to this video and re-watch parts of this video to kind of help you figure out how to do the homework. And of course, if you have any questions at any point, if something in the video was not clear, or even if using the video is still not helping clarify what you should do for the homework, email me, or you can reach out to me on Google Classroom. This is all going to be a learning experience for all of us. So section 8.1, adding and subtracting polynomials. First thing I'd like you to do is pause the video and give these 4 problems a try. You are simplifying each algebraic expression. Go ahead and do that now. Okay, so at this point you hopefully have paused the video, you gave the problems a try. I'm going to zoom in and show you what you should have gotten for each of these problems. So it says simplify each expression. Notice it does not say solve each equation. I know that these are not equations because there's no equal sign. All we can do is look for like terms to combine. So for number 1, you should have combined the negative 7x and the positive 2x and gotten negative 5x. And that's your final answer. For number 2, you should have combined the negative 8 with the negative 5 and gotten x minus 13. Final answer. Done. I can't combine the x and the 13. They are not like terms. This is all going back to Chapter 1. For number 3, I have a 1n and a 7n that I can combine to get a total of 8n. I also have a negative 10 and a positive 5, which I can combine to give me a negative 5. Done. Final answer. I can't combine those two any further. One has a variable n, the other is a constant. It has no variable. And last but not least, here's what you should have gotten for number 4. I have a positive 7 and a positive 6. I can combine those to get a positive 13. I have a negative 2x, a negative 2x. I can combine them and get a negative 4x. Done. Final answer. All right, dear children, if you can do this, you're in a pretty good place for today's lesson. If you can add and subtract like terms, you can add and subtract polynomials. And that's our goal for today. A little bit of vocab before we get started, something called a monomial. If you have never heard of something called a monomial before, here's how I'm going to define it. It's either a number, a variable, or the product, meaning we're multiplying, product of a number and variable. And of course you can have more than one variable. So I'm going to jump down to this part of the screen right here where my little arrow is pointing right here where it says examples of monomials. Here are some examples of monomials. It could be a number, like 5. That's a monomial. It can be a variable, like x, or even x squared. Those variables can have exponents on them. That's a monomial. Or it can be a product of a number and a variable. 5x squared is another example of a monomial. And as I mentioned, it doesn't have to just be one variable. I could have, for example, negative 3x squared y. All of those things are being multiplied together. That is also a monomial. Now, if you add and subtract monomials together, they form something known as a polynomial. So a polynomial, that's how I'm actually going to define it. It's not going to be the most eloquent textbook definition of a polynomial, but it is what a polynomial is. It's the sum slash difference of monomials. Monomials. Hopefully I spelled that right. So that means you're taking various monomials and you're adding or subtracting them. So here's going to be an example of a polynomial. Well, a monomial by itself could technically be a polynomial. Or I could take that monomial and add it with another monomial. There's another example of a polynomial. So one example of a polynomial is the number 5 because it's a monomial. Another example of a polynomial would be 5 plus x squared. So I'm adding those two monomials together. That's a polynomial. Poly means many. All right, here's another example of a polynomial. Let's say I had the product of 5 and x squared, and I subtracted 3x squared y. They are two different types of terms. Notice how I can't combine anything here. Let me use my little arrow again. I can't combine the 5 and the x squared. Just like in that little do now, in order to combine things, they have to be like terms. This is considered simplified. This is considered a polynomial. Same thing over here. I can't combine this x squared with this x squared. Yes, they both have x squared terms, but this one has a y attached to it. In order for things to be like terms, they have to match in not just their variables, but the respective exponents on those variables. And if there's any additional exponents on those terms, those variables have to match as well. So these are not like terms. So this is as simplified as it can get. This is an example of a polynomial. All right. The next thing that we're going to cover is known as the degree of a monomial. So the degree of a monomial, you're going to find that by looking at the exponents on the variables, just the variables, not the numbers, okay? And if you have more than one variable within that monomial, you're going to add those exponents. That's how you're going to get the degree of a monomial. So I'm going to say that the degree of a monomial is the highest exponent, highest exponent on a variable. I may have to shrink some of this because I'm going to have to expand this. It's going to be the highest exponent on a variable, or the highest sum of exponents on variables, plural. It might not make much sense based off of that definition, but I'm hoping through examples and practice you'll see what I mean. So when I look at example A, I see one variable, okay? This is a monomial, 5x. It's the product of the number 5 and the variable x. So it is a monomial, it's one term. To get the degree, I'm going to look at the exponent on that variable. So remember, in that definition it says it's the highest exponent on a variable. When I look at the variable x here, what's my exponent? Remember, if you don't see an exponent on a variable, there's an understood 1 there. So my degree is just going to be 1. It's just going to be that same value, which is the exponent. Okay? All right, let's look at example B. I have two variables. Well, if I go back to my definition, it says it's going to be the highest sum of exponents on the variables, plural. So I'm looking at both of my variables, and I'm going to add the exponents together. Now, some of you may be thinking, wait, we can't add those exponents. The bases aren't the same. Well, we're not using properties of exponents here. We are finding the degree of this monomial. That is different from properties of exponents. Okay? So if I add these two together, my degree here is going to be 5. 3 plus 2 gives me 5. All right, if I look at example C, do you see any variables? The answer is no, there's no variables. 4 does not have a variable. 4 is a constant. Its value will always be 4. So if you don't see a variable, can you guess what the degree is going to be? If there are 0 variables, your degree is 0. Okay? So that's how you find the degree of a monomial. If it has one variable, it's going to be the exponent on that variable. If you have 2 variables, you're going to add the exponents on those variables, and that's your degree. And the reason why I say it's the highest, okay, we're going to be looking at polynomials that have multiple terms. So not just monomials can you find the degree of. You can find degrees of polynomials as well. Okay, so in that case, we're going to have to look at this part of our definition where we're going to take the highest one. For monomials, it's easy. You just look at whatever variable or variables you see, and you take the exponent. And in the case of like multiple variables, you just add those exponents. All right, so here are a few for you to try. Please pause the video, give them a go, and then I will show you the solutions that you should have gotten for each of these. All right, so at this point, you've given them a go. I'm going to zoom in here. It says, what is the degree of each monomial? For number 1a, I have 2 separate variables, and each of those variables have their own exponents. So that means that this has an exponent of 1, and this has an exponent of 1. If I add these together, that's going to give me the degree of this monomial. The degree that you should have gotten here is 2. For 1b, same thing. You've got 2 variables. The y has an exponent of 4. The z has an exponent of 1. To get your degree, you're going to add these 2 exponents together. So my degree for this one is going to be 5. For 1c, you have 0 exponents. Your degree is 0. Okay? All right. So that's how you find the degree of a monomial. Let's talk about adding and subtracting monomials. You can add and subtract by doing what we did in the do now. All you're going to do is combine like terms. You're just going to add or subtract the coefficients. So it says, what is the sum or difference? Well, I have 3x squared plus 5x squared. If I add these coefficients together, I'm going to get 8x squared. Here's my final answer. For question B, I have 4x cubed y minus x cubed y. There's really an understood 1 here, so if I subtract these, I'm going to get 3x cubed y. Done. So if you can add and subtract, you can do this. Next thing that we're going to talk about in this lesson is something called standard form of a polynomial. Standard form of a polynomial is just the way that you're going to write the polynomial, the order that you're going to write the forms, okay? So standard form is basically you're gonna arrange the terms so that the exponents on the variables decrease from left to right. So I'm going to write that as our definition for standard form. You write the terms, write the individual terms of the polynomial. I may have to shrink here, shrink my definition so it fits. Polynomial. Write the terms of the polynomial so the exponents on the variables decrease. Let me shrink it a little bit. Decrease from left to right. That's what I'm trying to write here. They decrease from left to right. Let me try that again so it's a little more clear. They decrease from left to right. So when you look at this table here, all of these polynomials are written in standard form, okay? There's a lot of information that's being thrown at you in this table. The leftmost column, right here, is giving you examples of polynomials written in standard form. The column to the right of that is describing the degree of each of those polynomials. Something else that may or may not be new to you, you can name polynomials, and you can name them in two different ways. One way you can name a polynomial, so it's in this column that I'm circling right now, you can name it based off of its degree. And another way that you can name a polynomial is to count up the number of terms in that polynomial and then name it based off of the number of terms. So we're going to do examples of how to name polynomials based off of their degree, and also how to name polynomials based off of the number of terms. And what I'll do is, on this homework assignment that I'm going to be uploading, I'm going to ask you to do the following. I'm going to have you simplify polynomials. I'm going to have you write them in standard form, if they're not already written in standard form. And then I'm going to have you name them in both ways, naming it based off of the degree and naming it based off of the number of terms. So let's take a look at a few of these examples here. In the first row, right here, I'm going to use my little arrow to point at stuff. We have a polynomial. It's a monomial because there's only one term, but its degree is 0 because it has no variable. Based off of its degree, we call this a constant. You probably already knew that this was called a constant, but what you probably didn't know is that's the name based off of its degree. If you name it based off of the number of terms, well, this is just called a monomial. Okay, mono, meaning one. If you have two terms, we call it a binomial. So think of a bicycle. It has two wheels. A binomial has two terms. And this is going to have a degree of 1 because when I look at the variable, and there's only one that I see here, there is an understood 1 as the exponent here. So its degree is 1, and when that's the case, we say it's linear. Okay, so we describe this as linear. If you recall, if I had a y equals sitting in front of this 5x plus 9, and you graphed that, that would form a straight line. Y equals 5x plus 9 would be a straight line. So hopefully that kind of helps you remember that if it's degree 1, there's a 1 right here on this where this exponent would be, this is going to be linear. All right. If I look at this third example, I only have x's throughout. This term right here doesn't have a variable, its degree is 0. This term right here, its degree is 1. this term right here, its degree is 2. So if you recall, back in my definition, let me scroll all the way back up to that definition. If you hear Sue, that's Sue meowing. She hears me talking. All right. So if you look at this definition, it says you take the highest exponent, and that's your degree. So that's where that part of the definition comes into play here. The highest exponent here is 2. So that's going to be the degree of the polynomial. Same thing up here. The highest degree was 1. This term right here, this 9 that I'm circling, that had a degree of 0. The higher degree is 1, so that's why its degree was 1. The highest degree here is 2, so my degree is 2. My highest degree here is 3. That one should be obvious because it's just one term, so my degree is 3. In the last example, my highest degree is 4, so my degree is 4 here. So hopefully that kind of clarifies how you find the degree when there's more than one term. So let's just kind of wrap up with this third row as our final example. I'll let you read through the last 2 rows at your leisure. If you are confused on anything in this table, feel free to reach out. So when I look at this example here, and I count up all the separate monomials, and as you can see, they're separated by plus or minus signs, I have 1, 2, 3 different terms. Okay, so I have 3 terms. Based off of the number of terms, this would be called a trinomial. So if you think of a tricycle, that has 3 wheels, or a Triforce has 3 sections. If any of you guys are Legend of Zelda fans, a Triforce has 3 sections. That's known as a trinomial. Okay. Just a few other quick things. Beyond exponent of 3, I believe there are special names using the degree, like quartic, quintic. Your textbook doesn't give those special names. They just start using this kind of terminology, 4th degree, 5th degree. So that's how I'm going to basically teach it as well. Anything above a degree of 3, we're not going to have a special name. Okay, as you can see, when we look at these 1 through 3, they have special names based off of their degree: constant, linear, quadratic, and cubic. Anything above that, we're just going to say it's the nth degree, 4th degree, 5th degree, 6th degree, so on and so forth. And I believe that your textbook doesn't go above 3 terms when naming a polynomial based off of the number of terms. So our 3 options are going to be, it's a monomial, a binomial, or a trinomial. Those are going to be the 3 options. Whether or not polynomials with higher number of terms have special names, I don't know. It's possible. Your textbook doesn't cover it, so neither will I. All right, so let's do some examples. It says, write each polynomial in standard form. What is the name of the polynomial based on its degree and number of terms? So just reading the instructions here, I'm being asked to do 3 different things. First thing is, and I'm going to color code different parts here. The first thing is to write the polynomial in standard form. That means that when I look at this polynomial, I want whatever monomial has the highest degree to go first. So basically how I defined it was, when you look at the exponents on the variables, the highest one goes first, and then you decrease from left to right. So this term right here, this positive 4x squared, that's going to go first. And then the 3x, that has a degree of 1, that's going to go next. And then in between your monomials, you should have appropriate symbols. And if you're not sure what symbol to put in between here, where my arrow is pointing, you'll look at the sign of the next term. The 3x is understood to be positive because there's nothing to the left of it. So I'm going to put a positive symbol in between here, plus. And that is written in standard form. I have the degree of 2 as the first term, and then the degree of 1 as the second term. So the exponents on the variables are decreasing left to right. The next thing I'm being asked to do is to name it. So I'm going to color code things here based on its degree and also based on the number of terms. Let's do it based off of degree first. Well, first I need to figure out what is the degree of this polynomial. I look at the variables and I look at the monomial that has the highest degree. Remember, if you don't see an exponent, there's an understood 1 on it. So I have an exponent of 2 and I have an exponent of 1. This is degree 1, this is degree 2. The higher degree is the degree of the entire polynomial. So this polynomial is a degree 2 polynomial. Okay, so if its degree, based off of its degree, here's going to be the name. And if you're not sure what it is, go back to that table. Go back to this part of the video, pause it, okay? If your degree is 2, we call it a quadratic. This is a very special type of polynomial that we're going to work a lot with at the end of the school year. It's known as a quadratic. You may have heard this word before today's lesson. We're also going to name it based off of the number of terms. So here's going to be number of terms name. You simply count how many terms you have. I have 1, 2 different terms. So again, if you forgot based off of the number of terms what we call that, here it is in the table. 2 terms, we call it a binomial. So this is a binomial. And that question is done. I have done all parts of the instructions for that question. I'm going to do the same thing for part B. I'll try and go a little bit faster here. So first things first, I need to write this in standard form. This is degree 3. That's the highest degree that I see. It should go first. The next highest degree that I see, I'm actually seeing a tie. This is degree 1 and this is degree 1. So can you guess what I'm going to have to do here? I'm going to have to combine those. I should get 11x, and it's a positive, so I put a plus sign in front of it. That's going to be my degree 1 term. So sometimes you have to actually combine things in order to properly write it in standard form. And then the last term, which is degree 0, that's going to be my constant. That's going to be the negative 1. So there's the name, or excuse me, the standard form. And then let's see, what color did I use for based on its degree? I used blue. Okay. So based on its degree, my degree name, simply going to look at the first term. That's the benefit of actually writing it in standard form. To name it based off of its degree, just look at that very first one. Well, my degree is 3. So based off of my degree, we're going to name it as a cubic. And then number of terms, name. I have 1, 2, 3 terms. This is a trinomial. Hence why it's so important that you actually simplify it all the way. If you kept the 4x and the 7x as 2 separate terms, you would have gotten that part of the answer incorrect. You would have said it's a 4-term polynomial, and that's not true. It's not really a 4-term. It started off as a 4-term polynomial, but in its most simplified state, it is a trinomial. There should only be 3 terms in this polynomial. All right. So both of those are complete. What I'd like you to do is I'd like you to do the same thing for this polynomial. Here it is. I'm going to highlight it to bring your attention to it. Whoops. Let me try that again. It's this one. There's your polynomial, 2x minus 3 plus 8x squared. I want you to do the same thing I did. I first want you to write it in standard form, and then I want you to name it in two ways, based off of the degree and number of terms. Go ahead and pause the video and try now. Okay, so at this point, you've given it a go. Let me go ahead and I'm going to use the same color coordination. And here's what you should have gotten. For standard form, the 8x squared goes first, the positive 2x goes next, the negative 3 goes last. All right, I believe I used blue last time for the degree name. The degree of this polynomial is 2 because that's the highest exponent that I see. So this is a degree of 2. Based off of that degree, this is a quadratic. And then based on the number of terms, there's 3 terms, so this is a trinomial. So a lot of vocabulary in this lesson. Okay, so the last thing that we are going to cover is how to add and subtract polynomials. And as I mentioned in the do now, if you can do the do now, if you can add and subtract things, you can do this. Okay, so I'm going to do some examples with you. I'm going to give you 4 to try on your own, that you will pause the video, you'll give it a try, and then I'll just kind of quickly go through those solutions as well. So I'm going to zoom in here. So I'm subtracting 2 different polynomials here, each of which are contained in parentheses. This is kind of how your textbook formatted the problem, so this is how I formatted the problems as well, where I enclosed each polynomial in parentheses. When you are subtracting, the minus sign right here needs to be distributed into the polynomial that's just to the right. Okay, so think distributive property. So what I'm going to do first, okay, remember there's an imaginary negative 1 here. I'm going to distribute this negative 1 into the polynomial that's to the right, and in my next line of work, I'm going to drop all of the parentheses. So I can drop the first set. It's going to be the same exact thing, 7p squared plus 5 minus 3p. In the next polynomial, I'm going to get a negative 1p. Again, you don't have to write the 1 in front. It's understood to be there, but I'm going to write it there. And then negative 1 times negative 8, that gives me plus 8. All I did was I distributed into the second polynomial and dropped the parentheses. The next thing that I'm going to do is I'm going to look for terms to combine. The 7p squared doesn't have anything it can combine with, so that's just going to stay a 7p squared. But if I look at my next term, positive 5, it's a constant. I can combine this with the other constant of 8. That's going to give me positive 13. And then the next term after that is a negative 3p. I can combine this linear term with this linear term, negative 1p. That's going to give me negative 4p if I do that. Signs are the same, so I add them together. Last but not least, it is not good form to leave it like this. Good form is standard form. We should be practicing that when we do these types of problems. So you should always rewrite your polynomial in standard form if it's not already written that way. So I'm going to rewrite this. 7p squared has a degree of 2. That's the highest degree I see here. It goes first. The negative 4p has a degree of 1. That goes next. Positive 13 has a degree of 0. That should be last. Here's my final answer. All right, moving on to the second one. Don't be afraid of all these terms. We're just adding and subtracting. And same thing. You see this symbol in between here? There's a positive 1 that I'm actually going to distribute into the polynomial to the right. But if I multiply all of those terms by positive 1, that's not going to change the sign of any of those terms. So in my next line of work, I'm just going to drop all of the parentheses. I have a v to the power 4 plus 8 plus 4v plus 7v plus 8v squared minus 8 plus 5v to the power 4. And for really, really long problems like this, I sometimes like to cross things off as I take care of them. So as I go through this and I combine my like terms, I'm just going to cross terms off. So I'm going to start with the first one that I see. I see a 1v to the power 4. I'm going to combine that with any other v to the power 4s that I see. I only see one all the way at the end. I'm going to combine those and get 6v to the power 4. These are taken care of. I'm going to cross them out, so they're just not in my line of sight anymore. I'm going to look at the next term. I have a positive 8, that's a constant. I'm going to look in this entire polynomial to see if I have any other constants. Here's one all the way at the end, the negative 8. Well, if I combine those, what do you get? 0. So I'm not even going to bother writing plus 0. Okay, it's understood to be there if you don't write it in. So these are just canceling out. They're gone. Next term is a positive 4v. I'm going to look in this entire polynomial to see how many more linear terms do I have. I only see this one, which is 7v. If I combine them, I get a positive 11v. I'm also going to cross this out, so that way it's out of my line of vision. It's just cleaner that way for me visually. And then the last term does not have anything it can combine with, so I'm just going to bring it down. Plus 8v squared. This is also gone. And last but not least, I'm going to look at this polynomial to ensure that it's in standard form. It's not, because this term right here needs to be swapped. This quadratic term needs to be swapped with this linear term, because I want the exponents on the variables to decrease left to right. So I'm just going to move those two terms around. 6v to the 4th should stay at the front, and then plus 8v squared plus 11v. Now it's in standard form. Done. All right, I'm going to move on to this next one. Same as before, I'll try and go through this one a little bit quicker. Distribute, distribute, drop my parentheses. Distributing a positive 1 is not going to change anything. Everything stays exactly the same. The only thing we're doing different in this next step is we are dropping the parentheses. So the 3 stays positive, the 5x squared stays negative. I'm going to look at this first term, which is linear. I'm scanning the rest of the polynomial. I don't see any other linear terms, so I'm just going to bring that down in my next line of work. Now I'm looking at this constant of negative 6. I see another constant of positive 3. I add them and get negative 3. These are done. I cross them out. It's a little bit cleaner for me. I have a cubic, that's not a cubic. Hold on, Miss Lorette, that is a quadratic. I can't combine those two. All I can do with this cubic is bring it down in my next line of work. There's no other cubics that I see. And then the next term is a quadratic. I can combine this with the last quadratic. I should get negative 7x squared. These are gone. Last but not least, I'm going to rewrite this so that way it's in standard form. Negative 5x cubed should go first. Negative 7x squared should go second. Positive 2x, remember on this term right here, if there's nothing to the left of it, it's a positive. That should go next, and then the minus 3 is last. Done. Number 4, I'm going to distribute this negative 1 into the polynomial to the right. You're always distributing to the right. Okay, when you've got a symbol in between two polynomials like this, you are never, I'm going to do it in blue, you are never distributing to the left. That's wrong. Okay, you're never doing that. You're distributing to the right. So I'm going to simplify this and drop my parentheses. First polynomial stays the same. If I distribute a negative into the second polynomial, all it's going to do is flip the size of the terms. The 8 becomes negative 8. The plus x cubed becomes minus x cubed. The plus 3x squared becomes minus 3x squared. Next step, I'm going to combine like terms. I have a quadratic and a quadratic. I get 2x squared when I combine those. I'm going to cross them out so it cleans it up a little bit for me. I have a cubic and a cubic. I combine and get negative 4x cubed. These are gone. And then I have a constant. And then just glancing over it, all I have to do to write this in standard form, just put the negative 4x cubed in the front and the positive 2x squared in the middle. Negative 8 stays on the end. Done. Alright, so that is how to add and subtract polynomials. I'm going to move on to some problems that you can try. I highly recommend that you pause the video here, give them a go on your own, and then I will show you what the answers are. Alright, so now that you've given each of these a go, I'm going to zoom in, and I'm just going to quickly walk you through. I'm not really going to explain what I'm doing every step of the way, so it goes a little bit faster here. Here's what I get for number 1. Distribute. These cancel out. Combine. This doesn't have anything to combine with. And all I do is I flip them around to write it in standard form. This is of degree 1, the negative 6 is of degree 0. So that would be standard form like that. Number 2, distribute to the right. Drop my parentheses. I'm going to look for some cubic terms. Here's one. These are gone. I'm going to look for some degree 4 terms. Here's one. These are gone. I'm going to look for some constants. There aren't any. I bring this down. This is gone. I'm going to look for some linear terms. There aren't any. This just comes down. This is gone. And then I'm just going to ensure that it's written in standard form. 4th degree goes first. 3rd degree goes next. Linear term goes next. Degree 0, which is my constant, goes last. Number 3, I'm going to distribute. Drop my parentheses. And combine. Cubic, cubic, combine. These are gone. 4th degree, combine. They cancel. They are gone. Quadratic, quadratic, combine. These are gone. And hey, look at that. It's already in standard form. Didn't have to rewrite it. Works out nice that way. These polynomials are big. Distribute. Drop the parentheses. And I start combining. Constant. I don't see any others, so that's just going to come down in my work. 4th degree, 4th degree. That's going to be negative 9x to the power 4. These are gone. Linear, linear. That's going to give me plus 7x. These are gone. Quadratic, quadratic. That's going to give me negative 2x squared. These are gone. And I'm going to rewrite it in standard form. Fourth degree goes first. Quadratic goes next. Linear goes next. And then the constant goes last. All right. And that is it. We've covered a lot. So, like I said, I highly encourage that you go back to anything that we've covered in this lesson, rewatch it in case I was going a little too fast. Use this lesson to help you complete the homework. And if you have any questions, please feel free to reach out to me either through email or directly through Google Classroom. Take care.